What's up everybody and welcome to a new video. In the previous video we built the AI opponent, and now in this video we're gonna work on the game aesthetics. And here the first thing that I would like to do is to add actual columns. So currently our grid looks like this, where we have here these brackets from the Python list, we have these quotation marks, and we have here these commas. And I would like to get rid of them, and instead what I would like to do is to use here this vertical bar. So let's do that. So therefore let's copy here the code of this show function. And then here what we are currently doing is we are simply looping here over the grid, and then we're printing out the row. And the respective row is simply a list containing strings. So what we can do here is for this vertical bar character is to simply say or use the join method here, and then here put in the respective row. So let's do that. So let's copy this and then paste it into this print statement, and then here we're going to put in the row. So if I run it like this, then our grid now looks like this, where we have these columns. And the problem, however, with this join method is that it will only put this vertical bar here in between each element here of this list. So therefore then here at the beginning and at the end the vertical bar is missing, so therefore we have to manually add that. So let's do that. So we're going to here put in this vertical bar and then say plus, and then also do that at the end. So plus a vertical bar, and now if I run it like this, then we have our 7 columns. And here the grid looks a little bit narrow, so therefore I'm simply gonna add here some spaces around this vertical bar. So if I run it like this, then the grid now looks like this, and again here at the beginning and the end we have to manually add those spaces. So let's do that here and here, and now our grid looks like this. So next I would like to align again our column headers. So header 1 is already right above column 1, so therefore then let's look here at the 2. So this is slightly to the right, so therefore we simply have to remove here 1 space. So if I run like this, then it is aligned again. So then let's do the same thing for those other headers. So let's simply again here remove 1 space for each. And now if I run this again, then our column headers are aligned again. And then lastly, what I would like to do is to add here a horizontal line at the bottom of the grid. So therefore what we're going to do is we're going to use here a specific Unicode character, namely this overline character here. So let's copy this and then go back to the notebook. And then here, instead of printing this empty line, we're going to print this overline character. So let's see if it fits then our grid. So let's just add some more. So now it's fitting our grid. So let's then remove here this comment. And this is now our code for this show function. So let's copy this and paste it into this function. And then let's test if our code is working. So therefore then let's run here the file again. And here we're going to play 2-player mode. So this is now what the grid looks like. And now let's just play a couple of moves. And then here, as you can see, our code is working. So therefore then we can here check off this first point in our to-do list. Then the next point in our list is that we want to use colored dots instead of the X's and O's. So therefore we're gonna again make use of a Unicode character, namely gonna use here this black circle character. And then we're also gonna have to make use of some ANSI escape codes. Namely, we're going to make use of the escape codes for the color red, color yellow, and the color reset. So to do that, let's go back here to the Jupyter notebook. And then here to replace those X's and O's with red and yellow dots, I've prepared here 2 new constants. So the first one is called this color. This is simply a dictionary where the first key here is the first element in this players list. So that would be the X. And then the value here is the escape code for the color red. And then the second key is the second element in this players list, which is the O. And then here we have the escape code for the color yellow. And then here there's also a constant called color reset. So this contains the escape code for the color reset. Okay, so now let's use those constants here to replace the X's and O's with red and yellow dots. So therefore what we're going to do is we're going to create here a new variable, which is going to be an empty list. And that's the list that we're going to put into this join method here. And then to populate this list, what we're going to do is we're going to loop over each element in the row. And then if that element is an O, then we're going to append a yellow dot to the cells list. If it is an X, then we're going to append a red dot to the cells list. And if it is an empty cell, then we're going to simply append here this space to the cells list. So to do that, what we're going to say is here for cell in row. And then if that cell is equal to an empty cell, then we want to append it. So we're going to say cells.append cell. Otherwise, if it's not an empty cell, then it is an X or an O. And then we want to append a red or yellow dot. So we're going to say cells.append. And then here we first have to specify the color. So we have to access here this color constant. So we're going to say this color and then brackets. And then here we're going to put in the cell. So if the cell is an X, then we're going to access here the escape code for color red. If it is an O, then we're going to access the escape code for color yellow. So to that, we simply then going to add this black circle character. So here I have copy and paste it. And then after that, we have to reset the color. So we're going to say plus color reset. And that's already the code. So now we should replace here the X's and O's with red and yellow dots. So for example, these 3 X's here should be 3 red dots. So now let me run the cell to see if it's working. And as you can see, it is working. So this is now our new show function. So let's copy here this code and paste it into helper functions.py. And then we're also going to need here these constants. So let's copy and paste them. And now let's run the game to see if that is working. So let's play 2-player mode. And now let's make here a move in column 1. And as you can see, we have a red dot. And now let's make a move here in column 2. And here you can see we have a yellow dot. And here, one thing that I would like to change is that here it says player X, what column do you want to play? And then if we play here column 3, then we get here the red dot. And after that, it says then player O, what column do you want to play? And then if we play column 4, we get here this yellow dot. So therefore then, what I would like to do is to replace here the X and O simply with red and yellow. So we're going to say here player X is simply player red and player O is going to be player yellow. So now let's run the game again to see what it looks like. And now it says here player red, what column do we want to play? If we play column 1, then we have here the red dot. And then it says player yellow, what column do we want to play? And if we play column 2, then we have here this yellow dot. So as you can see, our code is working. So therefore, we can check off then here the next point in our to-do list. Then the next point in our list is that we want to overprint the existing grid. So currently, when we run the game, then every time we make a move, then a new grid gets printed. So as you can see here, for each new move here, we print a new grid. And what I would like to do is I would like to overprint the grid so that it looks like that it gets updated. So that's what we want to do now. And therefore, we're going to need 2 more NC escape codes. Namely, we're going to need the one for moving the cursor n lines up. And then we're also going to need the one for clearing the line. So now let's create this functionality for overprinting. So therefore, we're going to go here into the show function and create a new parameter. So we're going to call this overprint. And we're going to set the default value for that equal to false. Because that way then here we don't have to modify those function calls that we've already made. So for example, here at the beginning of the game, we want to print a new grid because there's nothing to overprint yet. And then here, when the game is over, and when we call this as play again function, then within that function, we also want to print a new grid because that's going to be the grid for the next game. So that's why then here we set this default parameter equal to false. And then within this function, what we're going to say is if overprint. So if that is true, then what we want to do is we want to move the cursor n lines up. And we're going to specify this n here in a moment. So then here to do that, what we're going to do, what we're going to say is print. And then here we put in this escape code for moving the cursor n lines up. And now let's count how many lines we want to move up. So therefore, let's run the game again. So then here what happens is when we press enter for this prompt is that the cursor here will move one line down. So then we are here. And then what we want to do is we want to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines up, so that we are then here at this empty line. So that way then we can then overprint the next grid or the previous grid. And then here, so then we're going to say here 10 and then make this also here 10 in the comment. And then here what we need to do in this print function is we need to set the end parameter equal to an empty string. And that's because by default, this is a new line character. So what would happen if we execute this print statement here is that the cursor would move one line down. So then in that way, we would then actually here be in this column header line. So that's why we have to set here the end parameter equal to an empty string. And with that, we are already done here within this show function. So therefore then here, when we execute the move and then call this function, let's simply set this overprint parameter equal to true. So now let's see if that works. So therefore let's stop here this game and then run it again. And now I'm going to make some couple of moves. And as you can see, it looks like here our grid is getting updated. So our code for the overprinting works. However, there's one problem with that, namely for this player yellow here, the prompt is a little bit longer than the prompt for player red. So for example, if I then play here column 4, then what happens is that these characters here from the prompt for player yellow are still depicted. So here we have this 4, the question mark and the Y. So to get rid of that, what we need to do is we actually need to clear this line here, this prompt line, before we overprint the new grid. So then here in our game.py file, before we execute the move and then overprint the grid, what we want to do is then clear this line. So therefore then again, what we need to do is here when we press enter, the cursor is going to move one line down. So therefore what we need to do is move one line up and then here clear this line. So let's write a comment for that. So let's say here, move the cursor one line up. So therefore then we can simply copy here this print statement. And then here we're going to say one line. And then obviously because we are already here moving one line up, then within this function here, we only need to move 9 lines up. So let's change that. And then after that, what we want to do is we want to clear the line. So therefore we're going to say then print. And then here we're going to put in the escape code for clearing the line. And here again, we have to set the end parameter equal to an empty string so that we don't jump to the next line. And that's already it. So now let's run the game again to see if that is working. And now if I make a couple of moves, you can see that we're always clearing the prompt line here. So our code is working. And now what I would like to do is I would like to put this code into its own helper function. So therefore let's go down here in our helper functions.py file. Then here we're going to create a new comment and going to say other functions. And here we're going to call this function simply clear previous line. And then here we're going to simply put in this code. So let's cut this and then paste it. And then within game.py, we're simply going to call this function. So clear previous line. So now let's test again if that is still working. And this time we're going to use here a one player mode to play against the AI to see if it also works with the AI. So now I'm just going to make a couple of moves. And as you can see, the prompt line is clearing. So as you can see, for the case that we provide valid input, our code for overprinting the grid and clearing the prompt line works. However, if we provide invalid input, then that breaks our code again. So to show what I mean by that, let's put in here an 8. So if I run it like this, then the output now looks like this, where we have here this message. The input must be a number between 1 and 7. Then we have here an empty line and then here the prompt. So what's happening is the following. So when we provide here the wrong input, then what happens is that this if statement here is triggered. So therefore then we print here this message. So that's why this is here then printed on the next line. Then this new line is created by this new line character. So this empty line here. And then once this print statement is executed, we get here to this continue statement. So therefore then we go back to the beginning of the while loop, and then here go back to this new prompt, which is then printed on the next line. So now this prompt here is 3 lines below this previous prompt. So therefore then when we overprint here the grid, the new grid is also going to be shifted down by 3 lines. So for example, if I play here column 1, then you can see that this new grid is now shifted down by 3 lines. So this is what we now want to fix. So therefore, to see what we want to do, let's print out this again, and then here again provide here an 8. So the first thing that we want to do is that we want this message here to be printed on the same line as the prompt. So in our code, therefore, then we simply have here to call our clear previous line function. So now let's see what that looks like. So therefore, let's run the game again, and again provide here an 8. So now this message is here printed on the same line as the previous prompt. So next we want to get rid of this new line here. So therefore then we simply need to remove here this new line character. So then again, let's run the game again to see what that now looks like. An 8. So now, as you can see, the new line is gone, or the empty line is gone. And now what we want to do is that this new prompt should also then be printed on the same line as this message here. So therefore then here in our code, we simply have to clear the line again. So we're going to say hf.clear previous line. And then here, because this message here gets printed between those clearing the lines code, what we have to do is we have to make the program wait for some time so that we can actually read the message. So we're going to say here time.sleep and then 2 seconds. So now let's run the code like this to see what that looks like. And again, let's provide here an 8. Then it says the input must be a number between 1 and 7. And then our prompt is again on this line. So therefore then if we overprint the grid, everything is working again. Okay, so that is now what the code looks like. And now again, I want to put this here into its own helper function. So we're going to call this simply give feedback. And here we're going to put in a message. So the message is simply going to be here this string. So then within the function, we're going to clear the previous line. Then we're going to print the message. Then we're going to wait for 2 seconds. So we're going to say time.sleep 2 seconds. And then we're going to clear the previous line again. And then here, as you can see, you actually also have to import this time module in this file here. So we're going to say import time. And that's our code. So now let's use that in our game.py file. So therefore, let's here get rid of these lines again. And then here, instead of saying print, we're going to simply say hf.give feedback. So now let's see if that is still working. And this time we're going to use 1-player mode against the AI to see if it also works for that. So we're going to here provide here an 8. Then it says the input must be a number between 1 and 7. And now let's play column 1. And as you can see, our code is working. So for the case that we provide here invalid input, we have now fixed this problem. And here, if the column is full, it's basically the same thing. So therefore, we're also going to say hf.give feedback. And then we get here rid of this new line character. So now let's test if that is working. So 2-player mode, and let's make now column 1 full. And now let's play column 1 again to see what happens. So we're going to say here, and then column 1 is already full, and the new prompt is again on the new line. So let's also provide here an 8 again. The input must be a number between 1 and 7. And if we play column 2, that is still working. So now our code is working. And therefore then we can check off here the next point in our to-do list. And then the next point in our list is that we want to animate the move. So currently, when we run the game, then it looks like that the dots are suddenly appearing out of nowhere. And what I would like to happen is that the dot starts here at the top of the grid and then moves down until it reaches its final position. So this is what we now want to implement. And therefore, we're going to need to make use of 2 more ANSI escape codes. Namely, we're going to need to use the codes for hiding and showing the cursor. Okay, so now let's implement that. And therefore, what we're going to do is we're going to create a new make move function. And since the new one is going to be similar to the old one, we can simply copy here this code. And then let's paste this. And the new function is going to be called make move with animation. And for this new function, we don't need here this to moves parameter, because this is only be used with within these AI functions. So within here simulate moves and within choose column AI. So therefore, let's then simply delete this parameter. And then we're also going to delete the respective code that belongs to that parameter. So then what we have left is here the following. So what we do here is we say for row in reversed range and rows. So with that, we would start at the bottom of the grid. Then we check if the respective position is an empty cell. If it is an empty cell, for example here, then we make our move and then return the grid. If it is not an empty cell like we have here, then we go to the next iteration of the for loop. So we go one row up and then again check if there's an empty cell or not. And we do that until we make our move. So that's this function. However, with this new function, with the make move with animation function, we actually want to start here at the top. So therefore then we're simply going to delete here this reversed function. Then when we are here at the top, for example here at this position, then again we want to check if there is an empty cell. If it is an empty cell, then we make our move. And then after that we're going to show the grid. So we're going to say show grid, and we're going to set the overprint parameter equal to true. And then after that, we want the program to wait for a short amount of time so that we can actually see the animation. So we're going to say time.sleep, and we're going to sleep for 0.1 seconds. Then what we want to do is we want to get here to the next row. So we want to get to the next iteration of this for loop. So therefore then we're going to put this return statement after this for loop. So then in the next iteration, we again check if there's an empty cell. If it is, then we make our move. And then after that, what we want to do is we want to reset the previous row. So we want to reset here then this row where we earlier made the move. So therefore then we can simply copy this part of the code. And then here we're going to say row -1. And this then should simply again be an empty cell. So obviously for the top row here, we can't do that. So therefore then we only want to reset here this previous row if row is not equal to 0. So that's what we want to do. And then we do that until we go to the bottom. And then here when we reach, for example, this cell, then this if statement here is not going to be true. So therefore what we're going to do is then simply break here our for loop. So this way then we break this for loop and then here return simply at the end the grid. So that's our new make move with animation function. So then let's use it here in our game.py. So here then we're going to say make move with animation. And then here this show function we don't need anymore because we are using it here within this make move with animation function. So that's already everything that we need to do. So now let's see if that is working. So therefore let's restart here the game. And then we're gonna make some moves. So as you can see, the animation is working. However, you can also see that we have here these cursor glitches. So to get rid of them, what we're gonna do is we're gonna hide the cursor before we here clear the previous line and then make our move with the animation. So let's make then here a new comment. So we're gonna say hide cursor. So we're going to then say here print, and here then we're simply going to use the escape code for hiding the cursor. And here again, we're going to set the end parameter equal to an empty string so that we don't move to the next line with this print statement. Then after the animation, we want to show the cursor again. So therefore then we can actually just copy here this print statement and then make this here an H. So now let's see what that looks like. So therefore let's restart here the game. And now if I make some moves here, then you can see it looks already a little bit better. However, the cursor is still shown here at the bottom right of the grid. And to get rid of that, what we can do is simply here in those print statements, set the flush parameter equal to true. So we're going to set that equal to true. So like this. And now let's run the game again. So let's start it over. And now, as you can see, if the human makes the move, then the cursor is still shown. However, for the AI, the cursor is here not shown. So if I make another move, then you can see that. So for the AI, it's not shown. And the reason why it's shown for the human is because of this input function here. Namely, this interacts in some way with this hiding of the cursor. So to get rid of that, what we have to do is, after this input function, we have to wait for a short amount of time. So I'm going to say time.sleep 0.1. Then let's make here a comment, small delay. So this way then the terminal can finish rendering before then here this animation starts. So now let's see what that looks like. So let's restart the game. And now, as you can see, the cursor is not shown anymore, and we then have our relatively smooth animations. So the code is working. However, there can be one problem, namely here in our code, when we hide the cursor, then we have to reach this line to show the cursor again. So if there happens to be an error within this part of the code, then the cursor will still be hidden. So for example, if I make here a move and then interrupt the animation, then the cursor will still be hidden. So if I now make the move and then interrupt this move, then you can see the cursor is now here hidden. So I can type something, however, you don't see the cursor. That's because we didn't reach here this line. So therefore, to show the cursor again, we have to run the file again and then reach here this line. So let's just make here a move and then let it run through. And then, as you can see, now we have our cursor again. So to prevent that from happening, what we're going to do is we're going to put this block of code here into a try block. So I'm going to say here try. And then where we show the cursor again, this is going to be put into a finally block. So let's indent that here. So this way then, this line here is executed, even if there is an error in these lines here. So now let's run the code again to see if that works. So again, I'm going to make a move and then interrupt the move. So as you can see, I've interrupted it. However, the cursor here is still shown. So our code now for the animation works. And now, however, one last thing that I would like to do is, since this make move function is only going to be used in the AI section, I want to put the, in the AI functions, I want to put this function here into the AI section of this file here. So let's do that. So let's just cut this and then we're going to paste it into the AI functions section. So now that we've done that, we can then now finally check off here this next point in our to-do list. Then the next point in our list is that we want to indicate where the move is about to be made. So to show what I mean by that, let's again run the file. Namely, what I would like to do is here in between the column headers and the grid, I would like to insert an empty line. And in that empty line, I want to indicate where the move is about to be made. So for example, if player red wants to play column 4, then a red dot should be depicted above column 4 before the animation starts. So that it then looks like as if you're holding the disk above the grid and then letting it drop into the grid. So this is what we want to do now. So therefore, let's go back to our show function. And then here we're going to create a new parameter. And we're going to call this column to indicate. And the default value is going to be none. And then here within the function, after we print the column headers, we're going to say if column to indicate is not none, then we want to do something. So for now, let's just put in here pass. And otherwise, if it is none, then we simply want to print here an empty line. So therefore then, because we now have this additional line, when we move here the cursor, we actually have to move it up by 10 lines and not just 9. So let's change that. And then let's now see what our grid looks like. So let's print it. So then here, as you can see, we now have this empty line, and here we want to indicate where the move is about to be made. So therefore then here in game.py, we're going to go to the section where we then execute the move. And before we do that, we want to indicate where that move is about to be made. So therefore, let's create here a comment. And here we're going to say indicate where the move is about to be made. And then here we print the grid. So we're going to say href.show grid. Then we're going to set the overprint parameter equal to true. And then we're going to use this new column to indicate parameter. So let's use it. And then here we're going to actually pass in a tuple. And this tuple is going to contain the current player so that we know if we should print a red dot or a yellow dot. And then obviously it also should contain the column so that we know what column the player wants to play. And then after that, we're going to make the program wait for a short amount of time. So we're going to say time.sleep. And here we pass in a 0.25. So that's already everything that we need to change here in game.py. So therefore, let's go back here to helper functions.py. And now let's see what we need to do instead of this pass here. Namely, the first thing that we're going to do is that we're going to store those values in this tuple here into respective variables. So let's simply copy them and then paste them here. Then we're going to say that this should be equal to column to indicate. Then after that, we're going to create a new variable called line. And this is going to be an empty string. And to this empty string, we're now going to add characters within a for loop. So therefore, we're going to simply loop over all the columns. So we're going to say for I in range n columns. And then here we want to add characters to this variable here. So we're going to say line plus equals, and then here we specify the characters. So now to know how many we need to add, let me here highlight the first column in our grid. Namely, here you can see that we need to add, or that we have here 4 characters. So we have 2 spaces, the column header, and then another space. And then if I highlight here the second column, then again here we have 4 characters, so 2 spaces, the column header, and again a space. So that's what we're going to do here in the string. So we're going to add 2 spaces, then an X for now, and then another space. And then after the for loop, we're going to simply print that line. So now let's see what that looks like. So let's run the game again. And now let's play column 4. And now as you can see, we have those X's here indicated, and they are exactly below those column headers. However, you can also see that they, after the move, they are still executed. So when we here run the make move with animation function, where we then also call the show function without the column to indicate parameter, then we want to overprint this line here with this print statement. However, here we're only printing an empty line. So therefore, what we need to do is here, we need to actually add here spaces. And so that we don't have to count them, I've prepared here the respective print statement. So let's just copy and paste that. So this is the amount of spaces that we need to overprint those X's. So now let's see if that is working. So let's run the file again. So now let's play column 4. And then as you can see, those X's are quickly depicted. So then in the next step, obviously, we only want to depict the X underneath the respective column that we want to play. So for example, if you want to play column 4, then the X should only be depicted here under column 4. So to achieve that, what we're going to say is if I is equal to the column, then we're going to add here the string with the X to our line variable. Otherwise, we're simply going to add 4 spaces. So then we're going to say line plus equals, and then here 4 spaces. So 1, 2, 3, 4. So now let's see if that is working. So let's run the file again. And now let's play column 4. So the X should only be depicted here under column header 4. And as you can see, it was the case. So now let's play column 3. And it was only depicted in 3. And so now let's just play 5 again. And then it was depicted for 5. So now this is also working. And now in the last step, what we want to do is obviously we want to depict either a red or a yellow dot. So therefore, to achieve that, what we're going to do is we're going to make this here an F string. And then instead of this X, we're going to use here a placeholder. And within that placeholder, we can simply copy this code that we used before to illustrate here those red and yellow dots. So let's paste this into this placeholder. And then here, instead of saying cell, what we're going to do is we're going to put in here the current player. So we're going to say current player. So here then we want to have this color of the current player. To that we add then here this black circle character. And then we're going to add to that color reset. So now let's see if that is working. So let's again here play for player red column 4. So therefore then here we should see a red dot. So let's see if that's the case. And as you can see, it was a red dot. And now for player yellow, we should see a yellow dot. So let's play column 3. And as you can see, it is working. So our code is working. So therefore then we can here check off the next point in our to-do list. And then the last point in our list is that we want to indicate the winning dots. So to show what I mean by that, I have prepared here this grid. So let's copy and paste that. And then let's run the game. So here we can make a winning move if we play column 6. So let's do that. And then here, as you can see, it says now player red has won. However, those winning dots here are not indicated. And I would like to write the code in such a way that they are indicated. So this is what we want to do now. And therefore, we're going to need to use here this last Unicode character, namely this white circle character. So we're going to indicate the winning dots with this hollow circle here. So then to indicate the winning dots, we obviously need to know what those winning dots are. And the function that determines that in our code is this for connected function. So what we did here is we created a moving window for each of these different directions. And then for each moving window, we created here the cells list, to which we appended then the cell based on this row offset and the column offset. So based on the coordinates of that cell. And then here we simply checked if all the cells in that cells list are the same. If that was the case, then we returned a true. Otherwise, if that if statement was never triggered, then we returned here a false. So this is how this function generally works. And now what we're going to do to modify it is the following. So we're going to say here, or we're going to create a new variable, which is called for connected. And this is going to be an empty list. And to that list, now we want to append here the coordinates of the winning dots. And then at the end, we simply return this for connected list. And the good thing about that is that if there are 4 connected dots, then there will be some elements in this list. So therefore then this for connected list will be interpreted as truthy. And if there are not 4 connected dots, then this for connected list will stay empty, and therefore it's going to be interpreted as falsy. So the general functionality of this function here doesn't change. So it also won't break our code in any other places. Okay, so now what we want to do is we want to append the coordinates of the winning dots to this empty list here. So therefore, what we're going to do is we're going to create here a new variable called coordinates, and it's also going to be an empty list. And to that, then we want to append here the row offset and the column offset. So then let's simply say here coordinates dot append, and then we're going to append here a tuple, and the first element is going to be the row offset, and the second element is going to be the column offset. And then here, when we reach this if statement, if all the cells in this cells list here are the same, then what we want to do is we want to extend this for connected list with the coordinates in this coordinates list. So therefore then we're simply going to say for connected dot extend, and here we put in the coordinates. And then after that, we could here return the for connected list. However, we're not going to do that, and that's because it's actually possible to have 4 connected dots in multiple directions. So, and I would also like to indicate those. So therefore, we're not going to return the for connected function in this place here, but instead we're just going to return it here at the end. So those are all the changes that we needed to make. So now let's test this function to see if it works. So therefore, we're going to go to this notebook here. And here I've prepared the same grid. So currently there are not 4 dots connected. So therefore then our function should here return an empty list. So let's see if that's the case. So I'm going to say is for connected and then put in the grid. And as you can see, it returned now an empty list. So now let's change here this one cell to a red. Then here we have now these 4 connected cells in these 2 directions. And now if I run this, this is for connected function again, we should get the coordinates of all those connected dots here. So let's run it. And here you can see we get those coordinates. So those first 4 tuples here are the coordinates of those horizontally connected dots. So they are all in row 2. And then here the column indices are 2, 3, 4, and 5. And then here those last 4 tuples, those are the coordinates of those connected dots in the diagonal left direction. So the first one is also going to be in row 2 in column 5. So this is this one. The next one is then here in row 3, column 4, which is this one, and so on. So as you can see, our function is working. So then the next thing that we have to change is that if we want to indicate the winning dots, then we obviously also have to change our show function, because that is printing the grid. So therefore, we're gonna here create a new parameter, and it's gonna be called also for connected. And the default value for that is gonna be an empty list. And I know by convention, you shouldn't actually be using a mutable object as a default value. However, since we are only looking up here this variable and not changing it, it's not really a problem. And I also have a video where I explain why you shouldn't be using mutable objects as default values. So if you want to know more about that, then I will put the link to that video into the video description. So now, however, what we need to change here in this function is first and foremost this line here, where we simply printed the dots. Namely, currently we are always printing here this full circle. However, since we want to indicate the winning dots, we have to here distinguish between the full circle and the hollow circle. And to do that, I've prepared here a new constant. So this constant here is simply called this type, and it is a dictionary. So the first key is a 0, and then the value is here this full circle, and the second key is a 1, and then the value is here this hollow circle. So now we have to use here this type constant in this place, and then I'm going to say here brackets, and then to access the respective this type, what we need to know is if this cell here is a winning dot or not. So we will need to know if this cell here is in this for connected list, and more specifically we need to know if the coordinates of this cell are in this for connected list. So to get those coordinates, what we're going to do is here in this for loop, instead of saying for row and grid, we're going to do the following. So we're going to use here the enumerate function, because then we get also the index. So we're going to then say here row index comma row in enumerate grid, and then here for cell in row we're going to do the same thing. So we're also going to use here enumerate, and then here we're going to have the column index, and then next we simply have to check if these coordinates here are in our for connected list. So therefore then we're going to say, or we're going to create here a tuple and then say row index comma column index, and we're going to check if that is in for connected. So this is then going to return a true or false. So let's put that into a variable, and we're going to call this is winner disk, and then we're going to simply use this variable here to access our dictionary. So if it is a winner disk, then this statement here will be true. So this statement here will be true. Then we're going to access here the 1. So we're going to get here this hollow circle. And if the statement here is not true, we're going to get a false. And therefore then here in our dictionary, we're going to access here the 0 key and get here the full circle. So that's already everything that we need to do. And then here, just as a side note, we can also use this type constant here in this place, where we indicate the column that we want to play. However, in this case, we always want to use this full disk. So therefore then we're simply going to say here brackets 0. So this is now the change that we want to make. So now let's test this function to see if it works. So therefore we're going to go back here to this notebook and we're going to restart it. And then here we're going to store this list here into a variable. So we're going to simply call this for connected. And then we're going to call the show function again with the grid and the for connected list. So let's see now if that works. And then here, as you can see, those connected dots are now indicated. So this function is also working. So now we simply need here to do this function call where we put also this for connected parameter into this show function in our helper functions here. And the place where we do that is here in our is game over function. So here we check if there's a winner. So if there is a winner, then we want to indicate the winning dots. So therefore we can simply here copy this code So we're also going to determine here the for connected variable, and here then we don't need this HF. Then what we're going to do is we're going to put this for connected variable into this if statement. And then lastly, we need to call here this show function. But here we're going to also set the overprint parameter equal to true. So now let's see if that is working. So let's run the game again. And then again, let's make a move in column 6. So now the player red has won, and as you can see, those winning dots here are now indicated. So as you can see, our code is working. So therefore then we can check off here the last point in our to-do list. And with that, then we've covered here all those to-do list, all those checkpoints. So therefore then let's also check off here this game aesthetics section. So with that, then we've reached the end of this video. And then in the next video, we're going to refactor the code into a class. So thanks for watching, and hopefully I will see you in the next video.